Hello everyone. Today I am going to discuss the third problem of Leetcode Weekly Contest 441, which is zero array transformation 4. So I found this problem quite interesting. So let's discuss about the problem statement first. We are given an integer array nums and a 2T array queries, where queries I has li, ri and val. So what we have to do, we have to select a subset of indices from li to ri from nums and decrement the value of each selected index by val, okay, by exactly val. Okay, now we have to find the minimum number of minimum non-negative value of k, such that after processing this k queries we have a zero array. Zero array means that all the elements in that array are zero. Okay, now let's take the first example, 202. In the first query, okay, in the first query we can choose any index from 0 to 2, any subset of index from 0 to 2, and decrement the value by 1. In the second operation we can choose any two index from 0 to 2, any subset of indices from 0 to 2, and decrement by the value of by 1. So let's write them here. So our initial array is 202. In the first query we can choose any value in any subset from 0 to 2 and decrement the value by 1. In the second operation also we can choose any two value from any subset of indexes from 0 to 2 and decrement the value by 1. Okay, so in the first query, let's say we have chosen the indexes 0 and 2. Okay, and in the second operation also, let's say we have chosen 0 comma 2. Okay, so after the first operation our array will become 101 because we'll decrement the value of this 2 by 1 and this 2 by 1. Okay, and after the second operation the value will be 0 0 0. Okay, so we can say that by performing only two operations we can make the array 0 array. So our answer will be 2. Here you can see our answer is 2. Now let's discuss about the brute force way to solve this problem. The brute force way to solve this problem will be to like what we can say. I have to think about the brute force solution actually. The brute force way could be to iterate over each query. Okay, iterate over each query and choose a subset. Okay, each query and choose a subset and check it is possible or not. Okay, so like it will be like 2 to the power n into q. So I am not going to discuss this 2 to the power n into q. Okay, this is not really possible. So let's think about some better way. Okay, so here what we can assume is that this is kind of similar to the knapsack problem. Knapsack problem means that let's say we have a set of integers. Okay, we have a set of integers, let's say 1 2 3, and we will choose that if taking a subset of integers it is possible to get a possible sum or not. Okay, it is possible to get a sum or not. Okay, now we'll check the like we'll check the constants and see that the constants are quite similar to the knapsack problem, right? Here nums length is only 10. Okay, and num size is less than equals to 1000. Okay, this is kind of similar to the knapsack problem where the sum is less than equals to 1000. Okay, um, so what we are doing, like how we are going to solve this problem with knapsack. Okay, so in the knapsack what we will do, like we have some recursion step with I, and let's say our sum. Okay, I sum. Okay, now what could be possibilities is that we'll ignore this value, ignore this specific index, and we will go to the next index I plus 1 and take the value sum. And otherwise another possibility is that we'll take this specific index and go to the next index. So there are two possibilities for knapsack problem: I plus 1 comma sum and I plus 1 comma sum plus a of I. Okay, a of I. So this is the way we will solve this problem. Only difference here is that we'll solve this problem differently for each index. We'll solve the knapsack problem differently for each index. And what are the this 1 2 3 values? 1 2 3 values will be our queries I values. Like this is the last value of queries I val I, that will give us the array a of I array. Okay, let's call it a will be all the val of i's. Okay, a will be all the val of i's. Okay, now you might say that we have to find the minimum possible index. So for that what we can do, we can take from I the ith index, ith query, and we'll go back to the 0th query. we'll go from ith query and go back to the 0th query. Okay, I'll explain in the code, you'll understand it better. I hope you understood how we solve the next step problem, and we'll use the same idea to solve this problem also. Okay, now let's go to the code first, then I will discuss the time complexity of the code. Okay, now let's go to the code. So this is the DP for the knapsack problem. If it is normal knapsack, we'll have indices and also the sum. But here another thing I have explained, that we'll solve this problem differently for each indexes in num. So that is the second parameter. Like it could be this second parameter is not changing, you can see in the code the second parameter is not changing, so we'll solve this problem separately for each index. Okay, now we'll come from behind, right? We'll come from the, let's say I will set a specific query index and we'll come back to the 0. That means we'll take all the possible queries from I to 0. Okay, now if I equals to -1, that means we have come to the base case. Now if val equals to 0, that means we have find our possible value. Okay, then we will return so instead of I comma sum, we can I plus 1 comma sum, we can also take not sum plus ai, we can take sum minus ai also. So initially we'll start from a specific value, and at the end we'll check that if after deleting all the elements from that value we achieved 0 or not. Okay, so if I equals to -1, we'll check if the value is 0 or not. Now this is the memorization case. If dp ij value is -1 not equals to -1, that means this value is present, we'll return the specific value. Now this is the knapsack problem, like I-1 j val. I have already explained, this will be I-1 and j val. J is not changing. And if for the second case, this arrow, right, sum minus ai, we have to consider the case that the index of the specific value j lies between our queries li and ri. J lies between queries li and ri. And another thing we have to check is that this ai is not greater than sum, right? This ai is not greater than sum, because we will not consider negative sum values. Okay, that two cases we have to consider. If this value is greater than equals to queries i2, and this index j lies between our li queries li and ri, then we'll go to I-1 j comma val minus queries i2. Okay, I hope you get it. This is quite straightforward. Okay, now one important edge case for this problem is that where all the values initially all the values in the nums is 0, then our answer will be 0. So I have taken that case separately. We have taken that I have checked that if all the values are equals to 0, then we'll just return 0. So this is the edge case I have handled. Okay, now we are going from backwards from q minus 1 to 0, and we have solved this problem for a particular value of I and j. Okay, so j is not changing, so we'll check that for specific value of I and j, the nums j sum is achievable or not. Okay, now this part recursion is done. Now we have to find the specific index, so we'll iterate from 0 to q. Now initially our flag is 1. Now we'll check that for a specific value j, the sum nums j is possible or not. If for any j the nums j is not possible, then we can say that for this from 0 to I, this 0 to I queries, this is not possible. So we'll just do flag equals to 0 and break. Now if flag equals to 1, that means from index 0 to I with queries from 0 to I, it is possible to achieve all the nums j sums. Okay, nums j sums. Then we'll just return I plus 1. That means our answer will be I plus 1. And if it is not possible for any of the indexes of the queries, we can just return -1. Okay, the overall time complexity is around 10 to the power 7. You can see overall time complexity is 10 to the power 7. So I hope you understood the problem. This is quite interesting implementation of the knapsack problem. Just we have to consider this knapsack problem separately for each and every index, and then it is easy. Okay, if you have any doubt in any part of the code or explanation, you can always ask in the comment section. I'll try to reply each and every comment. If you find this video helpful, please like the video, subscribe to the channel, and also share among your peers. Thank you for watching.